Today we're learning about exponential growth functions. Now we've dealt with linear functions in the past, and with linear functions you can always find the next value by adding or subtracting something. That's due to a constant rate of change. With an exponential function it's a little different. Instead of adding and subtracting each time, we're multiplying or dividing. So our first step is in understanding how to recognize an exponential function given a table. So in our first example, we're given a table of x's and y's, pairs of inputs with outputs. And so we want to determine a function based on the data they've given us. Now, one of the first things we need to determine is, are the x's going up by the same amount each time? The answer is yes. Each time they're going up by 1. Now, it's important that they're going up by the same amount each time in order to determine our function, but it's even more important right now that they're going up by 1 so that we can determine what we multiply by for each one we go up. So for each one our x goes up, what is our output multiplying by? Every time it multiplies by 2. So that's the first important part of our exponential function. Now, with a linear function, we got used to writing them with y equals mx plus b, where m was our rate of change and b was our initial value. With exponential functions, we have y equals a times b to the x, where a is our initial value and b is our constant ratio, what we're multiplying by each time. And so we've already found b in this case because b is what we multiply by each time, which in this case is 2. So all that's left is to find our starting value. Well, the way we find our starting value is we look at where x equals 0, and we get 8. That would be our a. But if you're unsure, you can just take any one point, we'll pick this one here, and plug that into the function. 32 for y, and 2 for x. 2 squared is 4, which means that a must be 8. So that gives us our final exponential function. Y equals 8, our starting value, and we multiply by 2 for every x value that we go up. That's all it takes to write an exponential equation. But let's look at them more in depth on a graph. Y equals 2 to the x power. Now here's how we evaluate this. Normally we're looking at y equals a times b to the x. In this case, what's our a? Well, since we don't see any extra number there, it must be 1, because 1 times 2 to the x would just be 2 to the x. So that means we're going to start at 1. What's our b? b is the base of the exponent, which is 2. So the a and the b tell us we're going to start at 1 and multiply by 2 as we go to the right. So that means when x is 0, our output is 1. We can check that just by plugging 0 in for x in our equation. 2 to the 0 is 1. When we go up 1, we've got to multiply by 2, and 1 times 2 is 2. Again, we can check that by plugging 1 into our equation, and 2 to the first power is 2. Multiplying by 2 again brings us up to 4, and 2 to the second power equals 4. Multiplying by 2 again brings us up to 8, and 2 to the third power is 8. And so we see that as we go to the right, we multiply by 2 because that's our base. And we get this curve in our function. Well, what about when we go to the left? Well, since going to the left is in the opposite direction, I need to do the opposite of multiplying by 2, which is dividing by 2. So as I go to the left, I should divide by 2, so starting at 1, dividing by 2 puts me at 1/2, which makes sense because if I plug in -1 for x, 2 to the -1 is 1/2. Dividing by 2 again puts me at 1/4, and 2 to the negative 2 is 1/4. And then 1/8 and 1/16, and so on. But you notice that those numbers, even though they're getting smaller and smaller and smaller, they're always going to be positive. There's no exponent that I can raise 2 to and get a negative number, which is important because I need to identify the domain and range of my function. Now remember that domain is all of the valid inputs. What values can I plug in for x? What type of numbers can I use for an exponent? Any number I want. I can use positive, negative, and even though I haven't learned how to do them yet, I can use fractions too. So I can use all real numbers as inputs. How about for my range? What am I going to get out? Well, as we said, we can't get out negative numbers. We can't even raise 0 because there's no exponent that I can raise 2 to and get a negative number or even 0. So my outputs are all greater than 0. So I'm going to write real numbers greater than 0. So my domain is any real number. My range is all real numbers greater than 0. We can see that from the graph. This graph will continue going left and right in both directions forever. But up and down, it stops going down. It continues to go down, but it never goes through 0 into the negative numbers. So that's what limits our range. All right, how about you give one a try? Give you y equals 5 to the x. Take a couple of minutes, try to graph that, and identify the domain and range for me, and then unpause the video and see how you did. Alright, so our basic form for an exponential function is a times b to the x. And again, we see that a is 1 in this case, and b is 5. Which means I need to start at 1. And as I go to the right, I have to multiply by 5. So this one is going to go up rather quickly, because 1 times 5, or 5 to the 1 power, is 5. 5 to the 2nd power is 25, which is way higher on my graph. So maybe to make this a little bit easier to see, I could shrink this graph down a little bit. Let's make this 5, 10, 15, 20. We'll go up by 5s. Still not going to get very far, because exponential functions get very big very fast. So as we said, starts at 1, which is now way down here. Let's make that a little smaller so it's easier to see. And then I multiply by 5 on my next point, and then my next point, I'm already at 25. My next point is at 125, which is still really high on the graph. Then as I go to the left, I've got to divide by 5. So I'm going down very fast, but again, never going to cross that x-axis. So I'm staying just above 0 all the way along there. Oops. And then I start to rise very quickly. And there's my exponential function. Now again, domain is the same. The domain is the set of inputs, and this is going to keep going left and right forever, so we have all real numbers. And our range is the same. It's going to go up forever, but it can't hit 0 or go below. So our range is all reals greater than 0. Alright, if you have any questions, feel free to ask. If not, you can get started on your homework.